Hey guys, welcome to your channel, Maths are Us. In this video, we are talking about how to prove real number, third number, is irrational. The third number, for example, it can be square root 3, square root 2, square root 5, and 6, etc. There's a lot. In this video, we try to use example square root 2 as example. The irrational number means square root 2. This number cannot be equal to two integers in fraction. These two numbers, a and b, are integers and also they share no common factor. In this case, we give them a name. We call this kind of number a co-prime number. So co-prime number are integers. They have no common factor other than 1, and they are non-reducible. For example, let's see two integer numbers, 3 and 6. 3 is odd number, 6 is even number. Are they co-prime number? 3 is prime. 6 is not a prime. But when they put together, are they co-prime? They are not, because they share a common factor. They share 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So they can be reducible. They can be simplified. In another example, let's see a number 36 over 3. Are they reducible? Yes, they are. They have share a common factor 3. 3 simplified is 1. 36 divided by 3 is 12. 12 over 1 is equal to 12. And another example, let's see square root 4. Square root 4 is not third. Square root 4 equal to positive 2 or negative 2. Let's see this example, 20 over 21. This is exactly co-prime because they cannot be simplified anymore. 20, although 20 is even number, 20 is not a prime number, but 20 and 21, they can't be any reducible. Now to prove square root 2 is not equal to a over b, firstly, we can assume square root 2 is equal to a over b. If in the end we find square root 2 is not equal to that, we can go back to this answer. To prove square root 2 is not equal to a over b, firstly, we can use contradiction way. That means we assume square root 2 is equal to a over b. If finally we can't prove square root 2 is equal to a over b, that means square root 2 is not equal to a over b. So square root 2 will be an irrational number. These kind of things, we call them proved by contradiction. Now let's start to prove. Firstly, we let square root 2 equal to two integers, a over b. As we know, both a and b are integers, and they share no common factor. They cannot be further simplified. Now, let's square in both sides. The square of square root 2 equal to 2. And right hand side equal to a squared over b squared. We move this equation, it becomes 2b squared equal to a squared. In this case, we can see a can be divided by 2. That means a squared is even number. Because anything can be divided by 2. For example, a, or for example 10, they can be divided by 2, equal to 4 and equal to 5. That means these numbers are even. So because a squared is even number, that means a times a is even number. A times a is even number, that means A is even number, because even number times even number will equal to another even number. An odd number times odd number, they are still odd number. For example, let's give two even number. For example, 4 times 4, 4 squared equal to 16. Let's give two odd number. Let's say 7 times 7, 7 squared equal to 49. It's still odd number. That's why we can say, because a squared can be divided by 2, that's why a squared is even number. Because a squared is even number, that's why a is even number. Now, let's express the even number a as 2k. As we know, all the even number can be expressed an integer times 2, right? For example, if we have a number 4, 4 times 2 equal to 8 is still even number. If we have a number 5 times 2, any number times 2, it becomes an even number. And by the way, how can we express odd number? The odd number can be written by any integer number times 2 plus 1. For example, if you have any integer number, let's say 3. 3 times 2 is 6. 6 is an even number. When even number plus 1, it becomes odd number. 6 plus 1 is 7. So now we set a as 2k. We substitute a as 2k back to this equation. When 2b squared equal to a squared, now it becomes 2k squared. We solve this equation. It's 2b squared equal to 2 squared is 4. 4k squared. Now we simplify by 2 in both sides. It becomes b squared equal to 2k squared. Now we can see the similar thing. Because b squared can be divided by 2. So because b squared is even, that's why b is even. Tells us both of a and b are even number. Because both a and b are even number, that's why a and b is reducible. Does that make sense? If we have two even numbers, for example, a and 4, any even number, two even numbers, put them together in a fraction. They are reducible. A over 4, they have common factor 4, so that's why it's 2. But in the condition we set, we can see a over b must be irreducible. That's why we can see this assumption is not satisfied. That's why we can conclude square root 2 is not equal to a over b. So that's why square root 2 is irrational. That's how we prove third number. For example, square root 2, square root 3, square root 5, square root 6 is irrational. Case closed. Thank you for watching. See ya.